Hello everyone, today I'm going to talk about the beta oxidation. Beta oxidation is a process of catabolizing fatty acids to acetyl coenzyme A molecules. In this lecture, I need a specific fatty acid, that is palmitic acid. Let me show you the structure of palmitic acid. Palmitic acid has 16 carbon atoms, and I'm going to show the first 4 specific one, okay? That is a palmitic acid having 16 carbon atoms, okay? And first carbon is carboxyl group, second carbon is alpha carbon, third carbon is beta carbon, okay? And this molecule is not activated yet in order to get into beta oxidation. So, before the beta oxidation, I need a step that is activating step, okay? So, how can I activate this molecule? Of course, I'm going to add a coenzyme A molecule, okay? I'm going to add a coenzyme A molecule. Good. But I need a molecule more need. Which molecule do I need more? Of course, while I am adding coenzyme A to palmitic acid, I need an energy. So, where the energy is coming from? Of course, the energy is coming from the ATP molecule. I need the ATP molecule's energy. But how many ATP do I use? Of course, I use 2 ATP, okay? 2 ATP is using in order to activating palmitic acid to palmitic coenzyme A molecule, okay? The molecule is generated is palmitic coenzyme A. Let me show you the structure of this molecule. That is the palmitic coenzyme A that is activated, okay? Now, that is ready to get into beta oxidation. Okay, beta oxidation consists of 4 steps. And first step is oxidizing step, because we are oxidizing the palmitic acid. Let me show you how this is happening. First of all, I need an enzyme, but what is this molecule? Before this step, I had a carboxyl group, but now I have a acyl group, right? So it's a palmitic acid, and it's also acyl coenzyme I, right? Palmitic coenzyme I is also acyl coenzyme I molecule. So the enzyme that I need is acyl coenzyme I dehydrogenase enzyme. Okay, acyl coenzyme A dehydrogenase enzyme, because I'm gonna oxidize this molecule. But how? I'm gonna take a hydrogen atom from alpha carbon and from beta carbon. So it will be oxidized. But what is this molecule? Of course, that is a anoyl coenzyme A molecule, okay? The name molecule is anoyl coenzyme A molecule because there is a double bond between alpha and beta carbon atoms, okay? Good. But what is the full name of this molecule? Let me show you. That is trans delta 2 anoyl coenzyme A molecule. Good. Because there's a double bond between alpha and beta carbon. There is an anoyl coenzyme A. But I have a lot of acyl coenzyme A dehydrogenase enzyme, but there is no acyl coenzyme A molecule because there is an anoyl coenzyme A molecule. What should I do then? Of course, I'm gonna do that adding water to this molecule and making this molecule saturated, okay? Let me show you how this process is happening. First of all, which enzyme do I need? Of course, anoyl coenzyme A hydratase enzyme. Why hydratase enzyme? Because I'm going to add water. Okay, I'm adding water, but water is dividing in 2 groups. one of them is hydrogen atoms and the another one is hydroxyl group. Hydrogen atom is gonna be together with alpha carbon and hydroxyl group is gonna be together with beta carbon. Let me show you the new structure. Okay, what is the name of this structure? There is alpha carbon, there is beta carbon, but I see that there is a hydroxyl group in the beta carbon, right? So I can say that the name of this molecule is beta hydroxy acyl coenzyme A molecule, okay? The name of this molecule is this. And the third step is starting. What I'm gonna do, there's acyl coenzyme A, and I have a lot of acyl coenzyme A dehydrogenase enzyme. So there is a oxidizing step, okay? But what is the name of this enzyme? Of course, beta hydroxy acyl coenzyme A dehydrogenase enzyme. Let me write it. Okay, and what is gonna happen? Focus on, please. I'm gonna take two hydrogen atoms from this molecule. And one of them is coming from this carbon, and one of them is coming from the hydroxide group. I'm gonna take two hydrogen atoms from this molecule, okay? And what is gonna happen? Which molecules I'm gonna generate? Yeah, that is a new molecule that I generate, and there was a hydroxyl group, and now there is a ketone group, right? And which carbon? Of course, beta carbon. Because what I did, I oxidized the beta carbon, and the name of this process is beta oxidation. You got this point, right? Okay. And the name of this molecule is beta keto acyl coenzyme A. Beta keto acyl coenzyme A molecule. That is the name of this molecule. Okay. And final step. Yes. That is the final step. Okay. What I'm gonna do? I'm gonna take the acetyl group from acyl coenzyme A molecule. So the enzyme that is working in this step is acyl coenzyme A, right? Acetyl transferase, right? Because I'm transferring the acetyl group from the acyl coenzyme A molecule. Good. What is the acetyl group? That is the acetyl group, right? Actually, that is acetyl coenzyme A molecule. Okay, I'm gonna do what? I'm gonna take this molecule, and what is left? That is the final step. I took acetyl coenzyme A molecule, okay? That is the acetyl coenzyme A molecule, and that is the new fatty acid. The first fatty acid that I used is palmitoic acid, and it had 16 carbon atoms. But now, the fatty acid that I have has 14 carbon atoms, right? And there is a double bond here. Okay, and there are a lot of coenzyme A molecule and a new coenzyme A molecule getting into this molecule, right? And again, there is a fatty acid, coenzyme A. And this step is happening again. This step is happening again, and again. So how many steps we are going to do? There is a 16 carbon atom, right? And there is a 2 carbon atom in the acetyl coenzyme A. And this process is going to happen 7 times. What is going to happen? This acetyl coenzyme A can be used in the TCA cycle because the substance that is getting into Krebs cycle is the acetyl coenzyme A. Let me remind you the steps of TCA cycle. Okay? There is an acetyl coenzyme A molecule and it's getting into this process. And the first thing is oxaloacetic acid, and these are getting together to citrate, right? Citrate, and then isocitrate, alpha ketoglutarate, and then that is succinate coenzyme A, and coenzyme A is getting out, and the left one is succinate and fumarate and malate and oxaloacetic acid. That was the TCA cycle. And I want you to remind that there was an enzyme that is isocitrate dehydrogenase enzyme, okay? And there is a alpha ketoglutarate dehydrogenase enzyme. So I'm gonna get NADH from the NAD plus, okay? And in this step again, I'm getting NADH from the NAD plus, right? Okay, I'm writing down. Good. But in this process, from the succinate to fumarate, there is a succinate dehydrogenase enzyme, okay? And the molecule that is formed is FADH2. That's important, and that's different from them. And that is FADH plus, that is FADH2. There is again a dehydrogenase enzyme that is malate dehydrogenase, and I'm taking NAD plus to NADH, okay? Then I used just a single acetyl coenzyme A molecule, but I get 3 NADH, right? 3 NADH and 1 FADH, but there is one molecule more. What is this? In this step, there is a GTP from the GDP, okay? I generated a GTP molecule, okay? From what? From just a single acetyl coenzyme A. But in palmiotic acid, how many carbons do I have? 16 carbon atoms. How many acetyl coenzyme A can I generate? Let me calculate it. Acetyl coenzyme A has 2 carbon atoms, and I have 16 carbon atoms totally. So there should be 8 acetyl coenzyme A molecule, right? 8 acetyl coenzyme A molecule that I can generate. But how many processes do I need? Of course, 7 processes. For 8 acetyl coenzyme A, I need 7 processes. So how many NADH and FADH I'm gonna generate? 7 NADH and 7 FADH I'm gonna generate, okay? And I'm gonna use 7 water molecules, and I used 2 ATP, don't forget it, okay? I used 2 ATP in order to activate palmitic acid to palmitic coenzyme A, because palmitic acid is not activated before the being palmitic coenzyme A. I used 2 ATP in order to make these two molecules together that are coenzyme A molecule and palmitic acid. So 2 ATP is used previously. Okay, good. But from one acetyl coenzyme A, I generated these molecules. But from 8 acetyl coenzyme A, how many molecules will I generate? Of course, 8 more, right? Good. Let me calculate then totally. I'm going to generate 24 plus 7 NADH, right? So it means 31 NADH that I generate. Good. And from 8 FADH2 and 7 FADH2, I'm going to generate totally 15 FADH2 molecules. Good. And thirdly, I'm going to have 8 GTP. Good. 8 GTP. And I used 2 ATP. Don't forget it. Okay? And as you know from the electron transport chain, I can generate 2.5 ATP molecules from just a single NADH molecule, right? So 2 plus 5 ATP I can generate. So it means 7.75 ATP molecule I'm going to generate from just the NADH molecules. And FADH, how many ATP can I generate from just a single FADH2? Of course, 1.5. From the electron transport chain, I can know it. Okay? Good. How many ATP I'm going to generate from the 15 FADH2 molecules? Of course, 22.5 ATP molecules. Okay? And GTP. GTP can be converted to ATP. So there is just a 1 ATP from GTP. Okay? There is 8 ATP. And I'm gonna add all of them together. How many ATP I generated from this process and this process? I'm gonna generate 108 ATP molecule just from this process. Okay? But 2 ATP I used in the beginning of this process. So minus 2, 106 ATP is left. Good. Let me summarize everything. First of all, I had a palmitic acid. That is a fatty acid. And it has 16 carbon atoms. And I'm gonna convert it to palmitic coenzyme A. But how? I'm gonna add coenzyme A molecule, right? Okay. But I need the ATP's energy in order to make this molecule together. Okay. And the molecule that I generate, palmitic coenzyme A. Okay. And this is also acyl coenzyme A because it has a acyl group, right? So I can start the beta oxidation. The first step of beta oxidation is oxidizing step. But which molecule is oxidizing? Okay, that is the palmitic coenzyme A. But what is the name of this enzyme? Of course, acyl coenzyme A, the hydrogenase enzyme, is working in this step. So what is generated? Of course, I'm going to take one hydrogen atom from alpha carbon and one hydrogen atom from beta carbon. So there should be a double bond between alpha and beta carbon. So the molecule that I generate is trans delta 2 enoyl coenzyme I. It's confusing, right? But the important thing that I need to know is enoyl coenzyme I. Okay? And as you can see, there's a double bond between alpha and beta carbon. Okay? And the second step is starting right now. This molecule is not saturated yet, and I have enoyl coenzyme A, and I need to acyl coenzyme A. So I should make this molecule saturated. okay? And the enzyme that is working in a step is an oil coenzyme A hydratase enzyme, right? Because I'm going to add water to this molecule, but water should be divided into two molecules. Which one? Hydrogen atoms and hydroxyl group, right? Hydrogen atoms is going to alpha carbon, hydroxyl group is going to beta carbon. So the structure that is generated is here. Beta carbon has hydroxyl group, right? So what is the name of this molecule? Beta hydroxy acyl coenzyme A molecule, right? So there is a third step of this process. There is the oxidizing step, and actually that is the most important point, I think, because that is the beta oxidation, and I'm oxidizing the beta carbon, right? Okay. The enzyme that I'm using is beta hydroxy acyl coenzyme A dehydrogenase enzyme, because the substrate is beta hydroxy acyl coenzyme A. Okay. And what I generated? I generated a keto group because I took hydrogen from hydroxyl group and the carbon atoms. So there should be a missing bond, and there is a double bond. Okay. Good. There is a keto group, but what is this name of this molecule? That is the beta keto acyl coenzyme A is the name of this molecule. Okay. And the last step is here. What is going to happen? There should be an enzyme. The name of this enzyme is, of course, acyl coenzyme A. Acyl coenzyme A acetyl transferase, okay? Because I'm taking acetyl group from the acyl coenzyme A molecule, right? And I'm transferring it into another process. Good. And the final step, in the final step, I generated acetyl coenzyme A molecule, good, and the fatty acid coenzyme A molecules, but the carbon number is different. The first molecule's carbon number is 16 carbon, but the final group is 14 carbons molecules. But I can use this fatty acid again to this process, okay? And how many acetyl coenzyme A can I generate from all of this process? Of course, 8 acetyl coenzyme A I'm gonna generate from this process. But how many process do I need? Again. How many process? Of course, 7 process do I need, because I'm gonna get 8 acetyl coenzyme A molecules. Good. From one of this process, I'm gonna use 1 hydrogen atoms, and I'm gonna generate FADH and NADH, right? Good. So from the 7 process, I'm gonna generate 7 NADH and 7 FADH too. Good. But these are the important points, right? I used 7 water from this, all of this process. I used 2 ATP from this process, okay? I make this molecule activated, but that is important, okay? And totally, how many NADH I generate from the TCA cycle and the beta oxidation? Of course, we should know the beta oxidation and the TCA cycle, but TCA cycle, let me remind you, there is a NADH, totally 3 NADH molecules, right? Okay. There is just a single FADH molecule, and there is a GTP molecule from the succinate coenzyme A to succinate molecule, right? Okay. Then, just a single acetyl coenzyme A, I generated 2 NADH, 1 FADH2, and 1 GTP. Good. But I have 8 acetyl coenzyme A. Then we can calculate it. 24 plus 7, 31 NADH, and 8 plus 7, 15 FADH2, and I have also 8 GTP, right? Okay. But as we know from the electron transport chain, I can generate 2.5 ATP from just a single NADH molecules, right? Okay. And I can generate FADH to 1.5 ATP. I know it from the 80s electron transport chain. Good. Then I can calculate these numbers. 77.5 ATP, 22.5 ATP, and 88 ATP. I can add them together, and there is a 108 ATP. But that is not the net ATP that I generated, because 2 ATP I used in there. So minus 2 is the net ATP. That is 106 ATP that I generated from all of this process. Beta oxidation and TCA cycle. Thank you for listening to me.